Welcome to Mimi's Math Channel. Today I will discuss three forms of a quadratic function. So we have standard form, factored form, it's also known as intercept form, that looks like this, vertex form, that looks like this. When you're looking at each form, you can quickly figure out key characteristics of a graph. For instance, if I'm looking at the standard form and I wanted to find the y-intercept, that my x values would have to be 0, then if I put a 0 here, anything that's multiplied times 0 will disappear. And the only thing that will be left is c. Y would equal this value. When I want to quickly find my y-intercept, I'm looking at my standard form. So if I wanted to know what my x-intercept would be, I would look at my factored or my intercept form, because what that means is I have to have a 0 in the place of y. So I would just set each one of my factors equal to this 0 and solve for x. And then with the vertex form, I could just look for HK, which is my vertex. So now let's look at those different forms with actual numbers. What I want you to understand is that each of these mean the same thing. So if I were to ask you to factor this standard form, this is what it would look like. If I multiply this back out, I would get back to the standard form. And I can also manipulate these forms to get to the vertex form. It's kind of like me asking several people to tell me different ways to show the value of 8. Someone may say 2 cubed. Someone may expand that and say 2 times 2 times 2, because that's what it means. And then someone may say, well, what about 4 times 2? And another person may even say, well, what's the cube root of 512? Well, guess what? All of this equals 8. Just a different way of stating the same thing. As I mentioned before, if I wanted to quickly figure out what my x-intercept was, I would look at the factored form. The way I teach my students is I say, what does x have to be to make y equal 0? And I do it for each one of my factors. Or you can just write it out for those people who can't see it that way. So x plus 4 is equal to 0. So what does x have to be? The opposite sign. And then you would do the same thing for this one. What does x have to be in order for that factor to equal 0? Because remember, f of x means y. And then you would say x would have to be positive 2. When you're writing your x-intercepts, they are points. So you want to write it as a coordinate. And we said that the 0 has to be in the place of y. So that's what my x-intercepts look like. Now, if we want to find the y-intercept, we know that the x has to be 0. So we're going to go to our standard form. Every time I see an x, I'm going to replace that with a 0. Well, when I do that, that's going to disappear. What does this f of x mean? It means y. So it's saying y is negative 8. However, it's an intercept. So we want it to be written as a point or a coordinate. And then vertex form, we're going to take our h and we're going to take our k and we're going to put it as a coordinate. Now, this one confuses people sometimes, because if I ask you what is h, you might want to say 1, but that's not true, because remember, if I look here, this is x minus h. So in order to get this plus sign, it has to be x minus negative 1. So again, the way I teach my students, I just say, what does x have to be to make this equal 0? And that's going to be negative 1. So that's just my x portion. Now I go back and I find my y portion. Do not change the sign. It's whatever is shown after the square. So that's my vertex. Now, if I know my vertex, I know my axis of symmetry, and I also know either my maximum or my min. My axis of symmetry has the letter x, and so does vertex. So I'm going to go to the x portion of my vertex. And when I write my axis of symmetry, I write it as x equals. I want to know if I have a minimum or a maximum. The way that you can tell is after your equal sign, if there is not a sign there, it is understood to be a positive sign. Well, think about it. If I am a positive person, am I going to go around with a frown or a smile? I am going to go around with a smile. So that indicates that my graph is going upward. If there was a negative sign after the equal sign, that would indicate that my graph is going to be negative. And if I am a negative person, I am going to frown. Since the graph is going upwards, that means that I have a minimum. My minimum is going to come from my vertex, my y value. So think of maximum and minimum height. Which way is that? Up and down, right? Up and down means y. Your axis of symmetry is your x value, and your minimum or your maximum will be your y value of your vertex. You just write the number for the y value. This is what the graph would look like if I were to put it in Desmos. Now what I am going to do is I'm going to show you, well, first off, you can't see the entire thing. So if you wanted to press shift and then click either your x-axis or your y-axis, depending on which one you want to move. Let's say we want to move that inward or outward so that we can see the numbers. Outward is better. And then we're going to go over here and we're going to type in the other forms to see what they look like. So what I noticed is that my factored form in blue overlaid the red. And when I type in the vertex form, it's going to overlay it as well because they all mean the same thing, like I mentioned before. So we now have the green graph, which is the vertex form. But if I wanted to know my x-intercepts, I can clearly see that the graph crosses the x-axis where it's -4 and 0, and then +2 and 0. This is what we wrote. My y-intercept is where my graph crosses the y-axis, 0, -8. My vertex is where it splits this parabola into two symmetric portions or parts, -1, -9. And again, your axis of symmetry is your x portion. This is what your axis of symmetry looks like when you type it in Desmos. So it is depicted as a dashed line, and that's your x value at -1. Your y value again is where your vertex is actually going up or down, which is your minimum or your max. Your minimum in this case is going to be your y value, which is -9. Interval of increase, decrease, positive, and negative are all your x values. However, it can be confusing if you're looking at the direction of your arrows. We always want to come from the left, which is -infinity, and we want to go towards the right, which is +infinity, because we're looking at our x values. So when I ask you where is it increasing, this is not increasing. This is decreasing. I'm going down. If I'm using my finger or my pencil, I'm decreasing. But at this point, I start to increase. So where am I increasing from? I'm looking at my x values. So I am increasing from -1 all the way over, because I'm extending this to the right, to +infinity. That's what my interval of increase would look like. We use parentheses for interval of increase because it's going through a point. It is not actually stopping. The interval of decrease, I am again not going up. I am decreasing down to this point. Well, where did I start? I started from the left, which is always -infinity. -infinity, and I kept going until I got to -1. What you should notice is you're going to have one -infinity, which is always in the first slot, and you will have a +infinity, which is always in the second slot. They will never swap places. And then the other thing that you will notice is that your number repeats, because you go up and then you come down, or vice versa. So now interval of positive and interval of negative. We are talking about our x-axis. Positive will be all of the numbers that are going up positive. Negative will be the ones that are below your x-axis, right? But we're still talking about the x values. As I look at my graph, I notice that on my x-axis, I have -4 and I have +2. This x-axis is neither positive or negative. This is where it actually changes from either positive down to negative or from negative to positive. So I know these two numbers will be in my actual result. I just need to figure out where to put them. For the part of the graph that's under the y-axis, it's just one continuous graph. So I know that I'm going to use these two numbers in one set of parentheses because it's one. So that's going to be -4, 2. Well, if I have one set of parentheses for my negative, by default, for my positive, if it's a quadratic, I am going to have two sets of parentheses. The left side is going to have to start with -infinity. I know that for a fact because I can never start with +infinity. And then I have above my x-axis two different pieces of a graph. So this part is positive, and then if I go over here, this part is positive for 1, 2 different parts of my graph. -infinity to this same point to +infinity. You read from left to right. So if you are doing this correctly, what should happen is you will have bookends with your infinity sign. So the negative comes first, the positive comes last, and in the middle, you're going to have the exact same numbers that you had for your other interval. If your graph were turned the opposite direction and it was turned upside down like this, and your x-axis went this way, then now now you would have your interval of positive would just be one set of parentheses, and then on the bottom you will notice your interval of negative will have two sets of parentheses, negative infinity, positive infinity, and then whatever the two numbers are that you used for your positive. That's how it's going to work. This is two separate parts. This is one whole part. Unless it's a word problem, your domain for quadratics will always be all real numbers. All real numbers can be shown as negative infinity, always comes first, and then positive infinity. You can do this symbol, or you can write all real numbers. There's more than one way to indicate all real numbers. Your range goes from bottom to top. What I'd like to visualize is if I were to take this y-axis and place it inside, starting at my minimum or my maximum inside of the graph, how many of these numbers can I fit inside of this graph? And remember, this graph has arrowheads that goes on forever, but I'm starting from the bottom. So my y-axis, if I were to place it in here, has the value of -9. -9, and then all of the numbers that go upward forever. My range will look like this. If you try to write your range starting off with a positive infinity, you're going to get it wrong. You will never have positive infinity first, never. You read from bottom to top or from left to right, and both of those start with a negative infinity. In behavior, as x approaches negative infinity, what's going on with f of x, which is your y, it's up or down, and then as x is approaching positive infinity, what's going on with your y? As x is my x-axis, as my graph is going towards negative infinity, which is all the way over here, the arrowhead that's closest to it, is it going towards positive infinity or towards negative infinity on the y-axis? That's all in behavior means. So as x is going towards negative infinity, y is going towards positive. Well, if this arrow is going towards positive, guess what? This one is as well. So your answer will be the same in this instance. So that is how you would actually find your key characteristics. So one more thing I did want to mention, if we were asked to find our axis of symmetry and it's not in a form, it's not like in this vertex form, let's say it's in standard form, then you want to actually use this formula, and that's going to give you your x value of your vertex. And in order to find your y value, you would have to go back and substitute. So if I were to substitute back into my standard form, my a is the number that's in front of my x squared, because a, b, and c are just numbers, not variables. B would be 2, so I'm going to replace this with -2 over 2 over a. Since there's nothing in front of the x squared, it's 1. And now I just simplify. So x is -1. That's what I'm going to put it in the place of my vertex. And then I'm going to take this -1 and substitute it in for my x values and simplify, and that's going to give me my y. After substituting my x values and then simplifying, my output is -9, which is the vertex that we already knew based off of looking at the vertex form. Also, if we wanted to find the axis of symmetry, but it was not in vertex form or standard form, but in fact it was in factored form, we would take the actual factors, add them together, divide by 2, and that would give us our axis of symmetry. So this is what that would look like. That's going to simplify down to -2 over 2, which also simplifies down to -1. So we knew that our axis of symmetry, which is x, is going to equal -1. So there's more than one way to actually find these values. It's just easier to quickly look at them when they're in certain forms. Thank you for watching. Please remember to like and subscribe. Have an amazing day.